I did not look at your test this weekend, but I'm almost done. I graded the front page. I just didn't grade the back page yet. I'll do that after y'all leave. Proud of y'all for the most part, though. Truthfully, I know you may not think so, but like there's the same question I've asked for I don't know how long, and I put down -2 for a bunch of students, and I didn't put it down hardly as all this year, comparatively. Just so y'all are doing really good. I'm proud of y'all. Okay, chapter 3. So today, this is kind of how I've got this laid out for this chapter. There's 3 sections in this one. So we'll do 3:1 today. 3:2, I actually have it split up on 2 parts. It covers so much information that if I try to do all of it in one day, I think it's just too much. So I'll split 3:2 up into 2 days. We'll do 3:3. We'll have some other stuff that we need to do. Our goal is to take this exam the day before fall break. Day before fall break, okay? Shanks. All right. So today, scatter plots and correlation. All right. So to set this chapter up, guys, this is going to be bivariate data. That's bivariate data. So 2 variables. This is the only chapter we're going to be dealing with 2 separate variables. Everything else in AP Stats is 1 variable, okay? And it's either categorical or it's numerical. So this is going to be dealing with 2 variables: height, weight, how old the tree is, how tall the tree is. Okay, 2 variables, bivariate data, okay? So univariate's 1 variable. That's, like I said, that's everything that you guys have done up until, now, and it's everything we're going to do after this is 1 variable, right? Just whatever we're getting. It's been in categorical or it's been numerical, okay? This is going to be bivariate data, bicycle, 2, okay? Bivariate. We don't deal with more than 2 variables in AP Stats. It starts to become a pretty big deal if you start getting into more variables than just the 2. So that's what we got. Here we go. So univariate, bivariate data. So kind of keep your head wrapped around that throughout this entire chapter, okay? Bivariate data, 2 variables, okay? And in order to display 2 variable data, we use a scatter plot. So you guys have to remember back when we started talking about this stuff, if it was categorical, right, we used bar graphs or we used circle graphs or we used mosaic plots, right? There were a couple others. Then we have numerical data or quantitative, where we can display that in a whole bunch of different ways, right? Dot plots, histograms, box and whiskers, stem and leaves, right? For bivariate data, we'll just a scatter plot, okay? So we'll have an x-axis and a y-axis. You guys, you've dealt with this throughout your all, and that's quadrant 1 typically, right? We don't deal with negatives. So we're just dealing with scatter plots. So whatever my x value is and my y value, and you just got scatter plots. Okay with all that? Good. It's supposed to, or we hope that it shows a relationship. Hopefully it shows a relationship between 2 quantitative variables. Okay? So again, what is a scatter plot? What you need to know from this slide right here is that we use a scatter plot for bivariate data. And like I said, it's the only thing. You may have even seen, those of you that did all the multiple choices, at some point you probably saw a choice of a scatter plot. And it probably didn't make any sense at all, because the only time we're ever going to use a scatter plot is bivariate data. Okay, so it shows a relationship between 2 quantitative variables. It's not going to be categorical. It's all going to be quantitative. We can't really do a color and how old. There's no correlation or there's nothing to do with categorical data. It's all quantitative. Okay, it's all quantitative. I don't think all this is like I said. You got an x variable and you got a y, right? So you got a horizontal axis and you got a vertical axis. A lot of times this is the one that's doing the explaining. Here we go. I don't want to go through this. you're starting to get too much stuff. And that's what you need to know. Know the scatter plots for bivariate data. Relationship between two quantities, the values of variable pillar, horizontal and vertical axis. Each individual appears as a point, right? So whatever those values line up to, they line up with a point. How to make it, I don't think you need to know. I don't think you're going to make one of these, right? But you'll have an x-axis and you have a y-axis. You can have a break in the axis. For instance, this could be 0, but you can show a break in it, but you can only show a break at the beginning. You can't show a break like in the data. So if this is 20 over here and this is 21, the next one has to be 22 and 23 and 24. But you can show a break at the beginning of it, okay? So we don't have to go all the way down to 0. Label them explanatory. So that would be your first homework questions, is talking about the explanatory. Which one's explaining the variable? Which one's doing the explaining? That's kind of like the old inputs, right? The f of x. That's the old inputs. Which one's doing the explaining? Okay? Which one's doing the explaining? And then the response is what's on the y. That's the one that that's the one we're trying to get explained. Okay? So we have an explanatory variable and a response variable. One that's trying to do the explaining, and somebody's trying to give me what the response is, right? How old the tree is, how tall the tree is. Hopefully how old it is going to explain how tall it is. How old you are, how big your shoe is. Okay? Hopefully. Sometimes we can flip-flop some of these. But explanatory, let's see how I put the X. Explanatory is the X. Response goes on the Y. Scale it, plot them, Let's talk about the explanatory. Again, this is the one we're trying to use to do the predicting. It's the one that kind of stands by itself. That's the one we're trying to use to do the predicting. That's the one we're trying to use to do the predicting. Yeah, try, wish, right? What we want to do. And then the response is the one we're hoping to predict. Again, kind of not necessarily just we're trying. Prediction is we're going to. That's kind of one of those words that we want to use a lot in this chapter. Predicting. We're predicting. Explanatory and response. All right. So like I said, I did a lot of notes up here. The only thing important right now is the scatter plot, and then the explanatory and the response. We use a scatter plot for bivariate data. Which one's the explanatory should go on the X. The response should go on the Y. Okay? Questions? Everybody okay? Couple pencils? Click. Okay. Big deal here, right? How to describe a scatter plot. You know that if it's a categorical data, high, low, something else. If it's numerical data, it's shape, center, spread. If it's a scatter plot, these are the things we describe. Okay? So the first thing is a direction. Give me a direction. Is it going uphill? Is it going downhill? Or is there just no direction whatsoever? It's typically either positive or negative or no. Positive or negative or none. And it's really not up for debate. Like, we always talk about squishy, where it's either going uphill or it's going downhill. Going uphill or it's going downhill. Hopefully you've done enough math to at least recognize if it's going uphill or downhill. Let's look at this one. Is that a positive association, negative association, or none? Good enough? Uphill? Positive? If it's going uphill, that's a positive slope. Okay? That one is negative. Okay with that? And then this one is nothing. Can't tell. Good? So, pretty easy to just tell me if it's going uphill or if it's going downhill or it's not, right? Then you're going to tell me a form, and I'm going to just give you two choices here. Basically, you're going to tell me it's linear or it's nonlinear. You can say curved or straight, but just tell me it's either linear or nonlinear. If you want to get fancy and you want to say it's quadratic or you want to say it's exponential, you can, but all they're going to look for is linear or nonlinear. And curved is easier for me to write than nonlinear. So we're looking for either a line or a curve. course, this one didn't. Is that one curved or was that one linear? See, this starts to get a little iffy, right? Probably linear on that one. Good enough. It's not really curved. This one, I think it's still linear, although there's somewhat of a curve in here. Good. Strength. This is what we're going to spend today on, telling me strength. You're going to tell me if it's strong, weak, moderate, strong. Those are the three words we tend to use. Weak, moderate, or strong. Weak, moderate, or strong. And that's what we're going to spend the rest of the day talking about, is the strength of these things. Okay? As we get through this chapter, you'll start to see this a whole lot easier. Okay? This is one of those squishy words. Okay? You might think it's really, really strong, and somebody else might just think it's somewhat strong. So, what happened there? Leave. Session timed out. Here we go. Apply. Beautiful. Can't outfox me. Click. And then anything that's weird about it, and again, guys, that's one of those things that they tend to not really grade that hard. They don't grade the unusual that hard unless they really ask about it. Okay, a lot of times something unusual just has to be so dang obvious that you just almost have to talk about it, or they're going to ask you about it. They're going to ask you about it. And then no matter what, always, 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 always in the context. Always in the context. Always in the context. When in doubt, you put it in context. I go back to the question that I had a grade last year. It was actually a shape, center, spread question. And it had an A part and a B part and a C part. And as long as you put context in one of those three, you were good. But it had to be in one of those. Most put it in the first, but negative, moderate, linear relationship between runs allowed and number of wins. You let more runs allow, you're probably not going to win as much. Good enough? Yep. Yeah, we'll talk about it in 3.2 and 3.3, but yeah, outliers, clusters, just anything that doesn't look like it fits. If you remove that point, it would be linear, something like that. That's good, yeah. Where'd that go? Let's go. Individual points that fall outside the overall pattern, distinct clusters. Again, it's going to be really obvious that there's something unusual. Most of the time, they don't really grade for unusual. That's not one of the things they're really looking for. Those don't show up in the rubrics. Those other three for sure will. Those show up. And then context. Those are the four things that do show up. This scatter plot shows an association between the mean SAT math score and the percent of students who took the SAT for the 50 United States. Describe the association. There is a, and you can say these in any order. They don't care as long as you get them in there. I think there's no doubt that the word negative should show up. There is a negative, probably curved. I don't think that one's really linear. I think that one has a curve to it. A negative, curved, somewhat strong. Again, this will mean more to you as we progress. Relationship between percent taken SAT and the mean math score. Good? Let's see. There is a moderately strong. They put that first. Negative, curved. Again, just get them in there. They don't care what order you talk about them. Try to make it somewhat nice, flowing. They use relationship. I use association a lot. Between, and then we're going to context. Okay? I can easily see a free response question on this, I'm hoping. Right? Been around long enough. Describe the distribution. It's kind of shape, center, spread. Kind of shape. Not really a center. Spread, tight. They did talk about the two clusters. Cluster here and a cluster here. They talked about this little point over here. But again, I don't think it's that outlandish to necessarily talk about it. The percent taken SAT is supposed to explain the mean math score. I don't know. Further, there are two distinct clusters and two unusual points that fall outside the overall pattern. And I don't know which point. I'm pretty sure we're talking about this point. I don't know. I'm guessing this point. I don't know if I'd talk about that one or not. Bless. Good? Yes, no, maybe? Anything? Click. All right, so let's spend the rest of the class talking about this correlation. Correlation. And it's known by three things, guys. It's known by correlation. It's known by correlation coefficient. It's known by correlation or correlation coefficient. Or because we're so lazy, we're just going to call it R. R. So if you see R, you have to associate that with correlation. You have to associate with the correlation coefficient. All three of those mean the same thing. I'm going to give you a lot of definitions in this chapter, maybe not as many as chapter 4, but there's going to be a lot. And you just got to know them. You got to be very comfortable with what they're telling us and how we need to use those values. So R is the first one we're going to talk about. Correlation. Correlation. And why they use R, I don't know, but they did. Correlation. Correlation coefficient, correlation, they're all three the same thing. R. R, correlation coefficient, and it tells me these things that we use to describe it. It tells me a direction. So this correlation will tell me a direction. It will tell me the strength, and it will tell me of a linear association. Okay? It will tell me the direction. It will tell me the strength of a linear association between those two variables. It will tell you a direction. It will tell you a strength of a linear relationship. And if you're asked, what does this tell me? It tells me the direction and the strength of a linear relationship. Because it will say, what is the correlation? And you tell them what it is, and then they will say, interpret this value. There is a strong or a weak, or whatever we want to say, negative or positive association. Okay? All right. We're good? Good. Let me give you some properties. This confused me a little bit, but it only tells me for linear. It only tells me for linear, so keep that in mind as we go through this, because I had some really good questions on this on Friday. Okay, here's some very important properties about this correlation. Okay? It's between -1 and 1. It's between -1 and 1. It will never be smaller than -1. It will never be bigger than 1. Decimals. These are decimals. Between -1 and 1. Okay? Between -1 and 1. And then the sign will match the direction. So if it's positive, that means it's going uphill. If it's negative, it's going downhill. Okay, so the sign of R will match the direction. That's like that's going to be a multiple choice one that's going to get you. That's like, I don't try to get you, but it's a get you. That's like a separating the A from the B or the B from the C question. That's a get you. But you have to know that the sign of R goes with the slope. Okay, if it's going uphill, then R has to be positive. If it's going downhill, R has to be negative. Okay? You will never see a -1 or a 1, but if you did, that means it's a perfect relationship. Over 3 up 1, over 3 up 1, over 3 up 1, over 3 up 1. I mean, it has to be perfect to be a +1. It has to be a perfect line. As soon as I put one that's not lined up with it, it will no longer be a 1. I don't think I've ever seen a 1. Ever seen a 1. -1 and 1 only occur in a perfect linear relationship. So here's one of my questions right here. I always thought that this was like really understood. So I'll tell you, one's 0.86, another's -0.86. Which one's stronger? They're the same. They're the same. Okay, so hoping we understood that. The only thing, this one's going downhill and this one's going uphill, but those are the exact same strength. Okay, so just that's something I always assume is understood. But and then as it gets stronger, it gets closer to 1 or -1. If it gets stronger, it gets closer to 1 or -1. And if it's weaker, it's going to get closer to 0. So as it gets stronger, it gets closer to the 1 or -1, depending on if it's going uphill or downhill. And as it gets weaker, it gets closer to 0. As it gets stronger, it gets closer to 1 or -1. As it gets weaker, it gets closer to 0. Again, these are things that I used to not put at all, but I just, as an assumption, has kind of come back and haunt me sometimes. All right. Give you a second to catch up there. Nappy time. Am I that born? It's a stick. I know. Okay. This is not etched in stone, but these are just numbers I kind of like to help you guys out with. Like, I don't know what I'm supposed to put. Anything between 0 and 0.5, we call that pretty weak. We say that's pretty weak. So then I was going, what if it's right at 0.5? You can say what you want. I'm just trying to help you out to try to put some numbers with some words. So anything between 0 and 0.5, I tend to call that fairly weak. That's not a great relationship. That's not a great relationship. 0.5 to 0.8, that's where we can start calling it moderate. Okay, and if you want to say moderately strong as you're getting, that's fine too. Or moderately weak, right? Again, just very few times are they going to ding you for lying, because you don't lie a whole lot on this stuff. I mean, it's pretty much strong or weak. And as you look at them, you'll start seeing this, right? And then between the 0.8 and the 0.1, that's kind of, we'll call that pretty strong. We'll call that pretty strong. I don't think the only time we take off for that is you just don't say anything. I mean, you forget to even put anything about the strength of it. Very few times does somebody mention the strength and it be the wrong strength. Everybody okay with that? Look up here. I got 6 different correlations, or I got 6 different scatter plots. Okay with that? I got 6 of them. 1, 2, 3, 4, 5, 6, and I got 6 correlations over there on the left-hand side. And at some point, they want me to match that. Now, bear in mind, it's almost impossible for me to look at that and tell you what it is. I can tell you that this one's negative, and I can tell you that one's positive. But other than that, what values they are, it's really hard to look at a scatter plot and tell you what it is. Okay? However, of those 6 up there, I think it's pretty obvious that number 6 is by far the strongest. No question. So I'll go over there and look at the one that's closest to the 1 or the negative one, and that one has to be closer to the negative one because it's going downhill. And so I can easily see, I'm guessing that that one's going to be the B. Okay? Now, from here, I think the next strongest one might be number 5. Number 4 might be close. And without knowing that they're going uphill or downhill, I couldn't tell you which one they were, but because they're going uphill or downhill, I can. So this one's going uphill, and that one's probably the next strongest one, and I think that one has to be 0.9 because it's closer than this one. It's a better one than this one. And this one must be the 0.5. And then that one's the negative 0.7. Kind of see how that goes now? Again, without me knowing that that fits between some of those, I couldn't tell you that that was a 7 at all. I can tell you it's negative, but I could guess a little bit. Nah, we're going to play the guessing game in a second. If you get it right, no homework. We're 0 for 2 so far. They did call the 1. They call that one like the 0. They called the 1 the 0, the worst out of all of those. Please, 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 correlation does not imply causation. The only way to show causation is with a experiment. Got to be an experiment. Got to be an experiment. Okay? Correlation does not measure form. So this is where my kids Friday had some issues with this statement. So, and I see why, and they were really asking great questions, and I predict the same thing's going to happen with you guys. So let that soak in for just a second. Correlation does not measure form. So here's what I'm going to tell you right now. R equals 0.98. Y'all okay? R equals 0.98. You would say there is a strong, positive, linear association between whatever. Good enough? However, that does not mean the data is linear. It doesn't mean that it's linear. It means that there's a strong linear correlation, but it doesn't mean it's linear. It could still be curved. Correlation does not measure the form. It just tells you if it's a strong, weak, positive, or negative linear association, but it doesn't tell me it's a line. Just soak it in. Okay? It doesn't tell me it's a line. It could be curved and still be a 0.98. It's just going to be really tightly curved that a line will fit it. Okay, soak that up. Just take that in. Just remember that. Because if I give you that on a test and you tell me that it's a line, you're wrong. If you tell me there's a strong positive linear association, you're right. But if you tell me it's a line, you're wrong. Because you don't know. The only way to know is with the scatter plot. Okay? So I can only use correlation with a linear relationship. I shouldn't. It only describes a linear relationship. Yeah. Y'all good with this? Any idea what you think R is? Zero. Because there's a horrible linear relationship. Okay with that? Horrible linear relationship. Does that mean there's no correlation? No, there's no linear correlation. Okay with that? So just those are things that kind of mess us up sometimes. Just because you see a zero doesn't mean there's no correlation. There's not any linear correlation. Just because you see R as 0.99 doesn't mean that there's a strong linear correlation. It doesn't mean it's a line. All right. Here's your formula how to calculate R. Oh, I didn't put it up there. How many times are you going to have to do this? Never. Okay? Here's what I want you to recognize, though, okay? Recognize it. So we got a 1 over n minus 1, which means we're kind of doing an average type thing. No big deal. But this is what? X minus x bar over standard deviation, which that's nothing more than a z-score. And then you got y minus y bar over the standard deviation of y's, and that's a z-score. And you're supposed to take those two z-scores and multiply them together. Okay with that? So just kind of take that in, but you'll never have to do all that stuff. They'll either give you R or your calculator will give you R. And I don't think the only way you're going to get it out of your calculator is you have to put all the data in there. And I don't think if you're starting to put a bunch of data in your calculator for a test, you're doing it wrong. Homework you may have to, but okay. So just kind of understand it's basically the z-score of that x and then multiplied by the z-score of the y. And I think that's important to know because I'm getting ready to give you some things that you need to know about correlation. Well, this is from the duh. They both got to be quantitative. Duh. They got to be quantitative. They cannot be categorical. I think there's a multiple choice question that deals with that. But I think it's one of those that everybody gets right because they're smart, because they're brilliant. And you know it can't be categorical. It has to be quantitative. Here's what you need to know, though. Because it was the z-score of the x multiplied by the z-score of the y, it doesn't matter if you switch the x and the y's. If you switch the x's and the y's, it's still going to be the exact same correlation. It's going to be the exact same correlation. Okay? So we got to know that. It remains the same even if you switch x and y. And not only will it do that, guys, it will remain the same if you change the units of measurements. And I can change the units of measurements of x, or I can change them of y, or I can change it of both. It remains the same because it's a z-score. It's that many standard deviations away from the mean, no matter what my unit of measurement is. It's the same z-score. So the correlation remains the same whether we switch x and y. It remains the same if we change the x, if we change it from inches to meters or meters to millimeters, and if I change the y's to feet. Doesn't matter. I can change one, both, or neither. And then R has no unit of measurement. R has no unit of measurement. So don't tell me that it's feet or inches or meters, or it has no unit of measurement, okay? And it's not a percent. It's not a percent. It's a decimal. It can't be bigger than 1. It can't be smaller than -1. It can't be bigger than 1. It can't be smaller than -1. Okay. Here we go. Whoops. You guess it right, there's no homework. Negative? Is it negative? Okay. Halfway right. Oh, I didn't go. Here, put it up here. Negative. Gotta get right to 3. That's why I said nobody's got it right yet. Can we do a 6? Can we do a 7? No, nobody's got close yet. Better be 0 point something. Oh, okay. 0 point. All right, now. 7, 8, 5. 7 or 8? 8? No? No? 7?
No, it's definitely 8. It's too high. It's like 8, 4, 7. It's just too high. 8, 4, 7. Can we all do our individual guesses? It's like an 8, 1.
You don't like group? Team.
I think 8's too high.
You think 8's too high?
It's not in the show.
Maybe like a higher.
7s.
Put your hand down.
8s.
What the heck? It's like, no.
Okay, 7, 9,
You guys are all
8. You think they're wrong?
9. Yes.
I really do.
I think that's You know what? Let them go. Let them be wrong. Girl.
Yeah.
My guess was 4, 7.
Oh!
You were quiet.
Okay, I'll give you another chance.
0. 0.0. There's no 0.
Uphill or downhill?
0.
That's positive. That's negative.
There, I'll give you another one. That was hard.
Negative 0.27. Is it really?
No.
Yes.
It's going
I think it's like 2 or 3.
It's like 5.
That's 7. It's like that's 7.
What you
No, it's not close to this line. It's close to it's like 0.2.
No, that's higher. 0.0 is higher than 2. No, it's not.
I think it's like 2 or 3.
265?
No, it's like
a
8.
0.5.
I like that. I like 265. I like that.
I told you.
Did you?
I think it's small. I think that's low. Ooh. Negative.
Ooh, this has got a little tricky in it.
I think it's a lot lower.
Because of that point there.
Oh, it's like at 100. 8, 8, 8. 8, 8. It's either 8, 8 or like 9, 2.
It's like a negative point.
No, the last negative. The last point's at 100. Negative 8. It's gonna be like 8, 9. Or 9, 1. No,
873?
it's like 8. Well, it's not 9, 1.
Oh,
Wait, I've been reading it over.
I thought it was a 9. Too bad. Guess y'all have to do your homework.
Well, like, just 3 points. 3 points. You can stop over here. You can shut up. You said 6, 7 words.
All right, psh, we'll finish. Yeah, okay. Guys, I hope you can distinguish between the explanatory and the response variable. A couple of your first homework questions are asking you which one's the explanatory and which one's the response. Make a scatter plot. Again, I don't think you'll have to make a scatter plot. Describe the direction, the form, and the strength of relationship. Make sure you can interpret the correlation. Interpret it, so that tells me the strength and direction of a linear relationship, and then understand the basic properties of correlation between how it correlates to those values. Okay? Very good. It should be posted.